We present Design Not Lost in Translation, a collaboration between researchers at UC Santa Cruz and King's College London and a company named Cottrell, with generous support from Committee for Children, in which we created an intimate space socially assistive robot for emotion regulation. Emotion regulation is now well understood as a key protective factor supporting personal well-being, with effects on life outcomes comparable in size to those of IQ or family social status. Constructive emotion regulation is crucial for maintaining child mental health. One challenge in teaching kids emotion regulation is that it's hard to deliver the skills practice in a just-in-time way when feelings are happening. We set out to design a toy that could scaffold children's emotion regulation skill in the moment in a way that was inviting and engaging for children. Our paper shows our design work toward meeting this challenge, from the creation of research prototypes all the way to translation of the core design to a commercial product. A crucial aspect of the design was creating a persona for the device that put it into relationship with the child. It was meant to be a creature in need of soothing and support that could thus help to scaffold a child's own self-soothing. In our article, we show the evolution of the creature's design alongside our design values and constraints. Here, top left, are mood boards that served as design inspiration. Top right, early sketches of ideas for the creature, and bottom, first soft 3D prototypes. A core concept that emerged as we designed the device was the notion of prioritizing intimate space interaction as understood by Edward Hall. By this we mean that the creature would be held close to the body and that interactions with it would take place through touch and haptic feedback. Building upon research that links fidgeting with various materials in particular manners to emotion regulation in children, for example, petting or stroking as self-soothing, we iterated a combination of affordances for touch and sensors that could track these touch traces with an onboard processor driving a haptic feedback loop. The creature would move from an anxious heartbeat to eventually relaxing into happy purring in response to touch. We workshopped our design with children, then refined it and created multiples that we sent out into multiple homes as a technical probe for a several-day period. The devices captured touch traces, which allowed us to sense how often they were being touched and which of the onboard sensors, as you can see from the visualization graphs here that show, on the left, average active minutes per day for each child, and on the right, touch trace patterns hour by hour over the trial period. We interviewed children and their families about how it was to have the device in-home. We found that children and families found the persona of the creature legible, understood and used the touch affordances, and were able to follow along with the core feedback loop to interpret how the creature was feeling. They also reported that the device did seem to support regulation of emotion. For more details, please see the journal article as well as related papers. Here are just a few quotes from the technology probe deployments. Just making the handful of research prototypes we did for the field tests took a lot of student labor. We really wanted the idea to scale now that we knew it had promise. Our sponsor, Committee for Children, located a development and commercialization partner, Cottrell. Together we launched into a translation process, handing off the theory of change, what we thought made the prototype work, and key design values in a series of online and in-person workshops. Cottrell adapted and evolved the concept, exploring different material qualities and also making modifications to the underlying sensing and actuation of the device that would better scale to mass production. They added some features, such as gentle sounds, and reduced others, such as some of the onboard sensors. Throughout this process, we were able to give feedback and suggest modifications that helped to keep the device on track for the end-user effects we had seen with the research prototype. Once they had a hardware prototype produced, we received copies of it, as well as ongoing updates to the software that drove the haptic interaction. This allowed us to have shared experience of the design and discuss nuanced iterations and adjustments. Their product, called Purble, has had a successful launch. and we feel it preserves the core design values that children resonated with in our research prototype. The research team has also been able to use the mass-produced devices to begin more robust trials of the device's efficacy, which has been a tremendous benefit of partnering with a commercial organization to work at scale. In considering what made the translation process go well, we offer 2 main points. 1, aligned values. It helped in this collaboration that the company already was very interested in the domain of socially assistive robots and had prior experience building robots for other health contexts. This meant that they were not trying to turn the prototype into a typical toy, but rather deeply understood the core design ideas. If possible, it's a great idea to find a commercial partner that already has relevant knowledge and experience. 2, ongoing communication and artifact sharing. It was important to the design translation process that we had ongoing communication and that we shared artifacts both early in the process and in the ongoing tuning phase. The in-person kickoff at the company allowed a rich dialogue about the nuances of the original design and helped the company to internalize key design values and build upon the original design thoughtfully. The sharing of the physical prototypes and then the code updates helped everyone to grasp and give feedback about the design evolution. One really could not understand changes in the core game loop and haptic cues without feeling them for oneself. Overall, the artifacts were very important as communication. The translation process also helped us to articulate the design space of intimate space socially assistive robots, which we describe in more detail in the paper. We realized that we could situate the creature, now known as Purple, alongside other devices that also have a persona that invites care, with touch affordances and feedback mechanisms and interaction loops that work within the intimate space zone. We think this design space may be of value to others interested in socially assistive robots aimed at supporting emotion regulation. To conclude, this talk has given a brief overview of our case study of the design and commercial translation of an intimate space socially assistive robot for emotion regulation. We hope this has inspired you to go and read the 2Chi article to learn more. Thanks for your attention.